Have you ever wondered what's going on right now on Mars or Jupiter or Saturn? Have you ever wondered if it even makes any sense at all to ask that question? Let's talk about the great people in physics that helped us answer it. The man who discovered physics is Isaac Newton. Isaac Newton publishes his Principia Mathematica in 1667. Now, a lot of other versions have come out since then, and in these new additions to the Principia, Newton also publishes notes to go along with the newer editions. In one of these editions, in 1713, something like that, Newton writes a scholium. He writes a general scholium that he puts at the end of the Principia. And in this general scholium, he writes a lot about God. He was extremely devout Anglican, Church of England, Freemason kind of guy, but very, very into God. And he writes about a God that's omnipotent and omniscient, and lots of other really good physics that went into understanding more and more about the universe. And Newton writes something about time, space, and motion in general in a very, very philosophical context, right? So physics is extremely mathematical. Without the mathematics, the physics is not what it is, the way that it's studied, especially today. But Newton was considered a natural philosopher. There was no such thing as physicists back then because Newton invented the field. And he writes these very philosophical notes about space and time. In particular, he makes it very clear that insofar as his experiments are concerned, there is absolute space and time. So there's a constant tick-tock in the universe. 1 second here is the same second that's happening on Mars and Jupiter and Saturn. This is Newton's account of time. And he gives us good reason to think this. One of these experiments that Newton comes up with is called the bucket experiment. If you take a bucket, fill it with water, and you rotate it, a concave shape will form on the surface of the water, and it'll go up some height onto the side of the bucket. Newton's idea was that if you're inside the bucket, you're seeing that the water concaves up. And from outside the bucket, you also see the same effect. It's not as if they're different. So both from the frame of being inside the bucket and outside the bucket, the water is concave. Newton used the bucket experiment to describe the difference between what he called relative motion and actual motion. And the fact that there wasn't a difference in these two reference frames, Newton wouldn't have called them reference frames, but from these two different points of view was an indication that there are absolute motion. It's not that relative motion doesn't exist, it's just that absolute motion is this realer kind of more fundamental thing. And he says that the same way that this exists for space, it also exists for time. Please like, comment, and subscribe. Thanks for listening if you made it this far.